Okay, so today we're going to be doing calculating moles. Having a look at our syllabus outcome, so we're moving on from what we did last lesson in just having a look at moles and what it is, an Avogadro's number. So we're actually going to be looking at calculating and manipulating masses and chemical amounts in moles of elements and compounds using N equals M over MM, which is our formula that we'll get to. Okay, so firstly, let's have a look at some revision questions. Just pause the video, have a go at answering these, and then come back. Okay, so if we have a look, um, mole is a unit of substance that allows us to compare quantities of reagents required in a reaction. 1 mole of atoms is equal to 6.022 by 10 to the 23 atoms. Molecular mass, also called the molar mass or the formula weight, is the mass in grams of 1 mole of that substance. And the units for molecular mass are grams per mole. So let's have a look at what we're doing today. So we're calculating moles. So last lesson we had a look at the mass of 1 mole of substance. So that's our molecular mass. Now, in chemistry, we usually need to go the other way. So we can't actually directly measure moles. Okay, we need to measure it through something that's actually measurable. So we usually start with mass and calculate moles from that. Okay, and that's important because again, yesterday we talked about how um, you know reactions happen on an atom per atom basis rather than mass by mass basis. Okay, so different elements have different masses, so every chemical is going to be different. And yeah, so we can actually calculate moles using the molar mass. The mathematical equation we use is this one. So it's moles equals mass over molecular mass. Um, our moles is measured in moles, obviously. Sometimes that's abbreviated to just MOL, and just like that. It has the symbol N. Okay, so you can think of it as N is the number of moles. Mass is measured in grams, it has the symbol M, and molecular mass is measured in grams per mole and has the symbol MM. Okay. And so when we put that together, we start with this equation and it gives us this with the symbols. Now this is the one that's on your formula sheet, so it'll be there if you ever need it. You just got to remember what N, M, and MM stand for. So having a look at some examples, how do we use this? So have a look at this question. So calculate the number of moles contained in 5 grams of sodium chloride. So how do we answer this question? So typically I like to break it down, start highlighting important information, especially because when it gets to HSC level, you can get a lot of information in a question. So if you get in the habit now of highlighting the important stuff, um, you know, that will be kind of second nature by the time you get to the HSC. So stuff that I like to highlight include any quantities and any units that are given to us, any chemicals or reagents, any special phrases. There's none really here, but when I mean special phrases, it's things like in physics we say at rest means a velocity of 0. So it's when we say words that actually give us quantities. In chemistry, it's things like initially there's X amount of moles per liter or something like that. And we also want to highlight what we're actually being asked to find. So having a look at our question, starts going through it. We can see there's a number at the end of the first line. That's 5. So it's 5 grams. That's an important piece of information. It also tells us what that 5 grams is made of. So it's 5 grams of sodium chloride. And lastly, we're told that we need to calculate the number of moles. Now that we've highlighted that information, we write it down. So mass is 5 grams. The chemical is sodium chloride. And our question mark, so what we're trying to find is N. Now, in a lot of multi-mark questions in exams, just putting down some relevant information like this is enough to at least get 1 mark. Okay, so quite often there's provide some relevant information, and that's the relevant information that we're looking for. Um, Now, how do we answer it? Well, we know from our formula that we need to calculate molecular mass, and we're given the chemical, which is sodium chloride. So just like last time, we add up the chemical masses, so the molecular masses of each individual atom. And we get, in this case, we get 35.45 for chlorine plus 22.99 for sodium, which gives us 58.44 grams per mole. So we use our formula, N equals M over MM. So N is our question mark, our mass was 5, and our molecular mass is 58.44. Just stick that in your calculator, and we get that as an answer. Okay. So, example number 2. Calculate the number of moles contained in 3.8 grams of silver bromide. So again, we go through it. Let's highlight the important information. So firstly, we get given 3.8 grams. Okay, so that's a mass. We're told silver bromide, that's our chemical. And we're also, again, told to calculate the number of moles. So write that information down. Mass is 3.8 grams. Chemical is silver bromide. And the number of moles is our question mark. We also need to calculate the molecular mass. That should say silver bromide. So I've actually changed the numbers, thankfully. So molecular mass is 107.9 for silver and 79.90 for bromine. So silver bromide is 1-to-1, so it's just AgBr. So it's just 1 silver, 1 bromine. Gives us 187.8 grams per mole. We then write down a formula, N equals M over MM. So our N equals 3.8 over 187.8. Gives us 0.0202 moles. Okay. Now, sometimes when we're calculating moles, we might have to go the other way. Okay. I know I did say we can't directly measure moles, but in a subject we call stoichiometry, which is actually what we're going to be doing next, sometimes we have to go from moles to mass. Now, or we might have to find the molecular mass given moles and weight. Okay. So we can use the rearranged equation. So here we have mass is number of moles times molecular mass, or our molecular mass is our mass over our moles. So again, that's just algebraically rearranging our original equation into these other forms that we can solve. Okay. Now these two aren't actually on our formula sheet, just that first one. So you have to try and, if you're not comfortable with algebraic manipulation, you have to work on that a little bit. So, example 3, calculate the mass contained in 0.2 moles of carbon dioxide. So again, going through, highlighting our important information. Reading through the question, we hit a 0.2, so that's an important number. So it's 0.2 moles, and it tells us it's 0.2 moles of carbon dioxide. So that's our chemical. And the question is asking us to calculate the mass. So how do we do this? Again, write down our information. Our N is 0.2, our chemical is carbon dioxide, and our mass is our question mark. Figure out the molecular mass of carbon dioxide. So it's carbon dioxide, 1 carbon, 2 oxygens. So 12.01 plus 2 times 16 gives us 44.01 grams per mole. Now, using our new formula, so M equals N times MM, so moles times molecular mass, gives us mass equals 0.2 times 44.01, which is 8.802 grams. So if we had 0.2 moles of carbon dioxide, it would weigh 8.8 grams. Now, one last example. This is one where we're having to calculate the molecular mass based on the weight and the number of moles. So, and then we're asked to identify the compounds that this compound could be. So, going through, highlighting numbers, so we have 15 moles, it weighs 300.12 grams, and we're told to calculate the molecular mass. So, N equals 15, M equals 300, and our mm equals question mark. So let's put into the equation mm equals mass over moles. So 300.12 over 15, which gives us 58.44 grams per mole. Actually, no, that's not right. Hold on. Sorry, I did have to change the numbers at a last minute. So it actually should be 20.008 grams per mole. Okay, so yeah, ignore that number there. It's 20.008 grams per mole. So what could that be? So which compounds could have the molecular mass? Well, the answer in this case is hydrofluoric acid. So we have fluorine, which is 19.00, hydrogen, which is 1.008. Okay, adding together, it gets 20.008 grams per mole. Okay. Um, yeah, so that's the end of the examples. Let's just do a quick summary. So our moles, they can't be directly measured, so they're usually calculating using mass and molecular mass. And the equation that relates them is N equals M over MM, where N is our moles, M is our mass, MM is molecular mass. Okay, so there will be a worksheet on that in the drive, so make sure you're doing that. And yeah, if any questions, come find me. Thanks.